Hello friends, welcome to the sixth video on number theory. This video will talk about how to find the GCD of any two given integers using Euclid's algorithm. So first we will see what is meant by a GCD and how we can apply the algorithm of Euclid to find what is going to be the GCD of any two integers. Moving on, we see what is meant by a greatest common divisor. Say suppose you have been given with two integers a and b. Then a common divisor d, which is not equal to 0, is an integer that divides both a as well as b. The word divisor and factor both mean the same to us. Okay, keep in mind divisor and factor both mean the same. If in addition a and b are both non-zero and we are able to find the greatest of the common divisor, then that is denoted as GCD of a and b. Hence, what is going to be GCD? Of all the common divisors which we have, we find which is the greatest, biggest of all, and then that we denote it by the term GCD. Say for example, we have the elements 24 and 42. Now, I know that 24, 42 are both divisible by the numbers 1, because 1 divides 24 as well as 1 divides 42. The number 2 as 2 divides 24 and 2 divides 42. Number 3, 3 divides 24 and 3 divides 42. Number 6 as 6 divides 24 as well as 6 divides 42. Now, we can also add a plus or minus to these quantities, as both the integers plus 2 and minus 2 divides 24 as well as 42, and in case all of the positive and the negative values of the quantity divides 24 and 42. Hence, now these quantities, which is plus or minus 1, plus or minus 2, plus or minus 3 and plus or minus 6, are referred as the common divisors or common factors. Now, considering these number, which is the biggest of them? The biggest number is going to be plus 6, and hence this plus 6 is referred as the greatest of the common divisors. Hence, the GCD of the number 24 and 42 is referred as 6. Now, this GCD can be found using many different techniques. We are going to learn one of the important techniques which will more frequently applicable in the field of cryptography. Cryptography is the process of encrypting messages so that it is secure and you pass it on safe to other peoples without revealing the data to others. Okay, so how does this Euclid's algorithm work is what we are going to see now. So the primary aim of Euclid's algorithm, what is going to be the aim, is to find the GCD of the given two numbers a and b. So what is taken as input? Input is the two integers a and b. What is given as the output? I get GCD of a and b as the output, which I am going to store it in the variable called as g. So the output common divisor g of what? Of the elements a and b. Now, we will see how the algorithm works. First, we need the process of initialization. I need to check that I will have to divide a by b, in which case you will have to have the quantity b to b. You will have to divide the integers by the common value. Okay, so what you have to know is you will have to check if always b is going to be smaller than that of a. So, in case if you have a to be less than b, then what you will have to do? You will have to exchange your a and b. So, always the biggest number becomes your value for a and the smallest number becomes b. The biggest number becomes a and the smallest of the two numbers become b. Now, what you will have to do? You will have to divide a by b, and then you will have to get the remainder r. If the remainder happens to be 0, like say suppose if you have 24 and you will have to be equal to 2. Okay, so what happens? I divide 24 by 2. If I divide 24 by 2, then it goes 12 times, and then what happens? You will have it go to 24 times, and then what will happen? 12 2s are 24, remainder becomes 0. If the remainder becomes 0, then report B as the GCD, the greatest of the common divisor of 24 and 2 will now be the value 2. This 2 is going to be the element which is greatest of all the common divisors of 24 and 2. If not, the remainder is not turning out as 0, then what you will have to do? You will have to repeat the algorithm. How to repeat the algorithm? Replace the value of A by B and replace the value of B by R and move back to your step 2. Repeat the process of dividing one by the other again. So when we stop the algorithm, that is going to be a point to be noted, right? So we stop the algorithm when the remainder happens to be equal to 0. So when the remainder turns out as 0, then the algorithm stops. And whatever is in the position of B, then this B is reported as the GCD. Can we now move to applying this algorithm to problem? Yes, come on, let's get started. Use Euclid's algorithm to find the GCD of the numbers 1819 and 3587. So it is the GCD of 1819 and 3587. So I see that this is my A and B, this is my B. My A is going to be smaller than that of B. I need to know always that A has to be big. So I swap the elements. So I interchange the elements. So I write it as find the GCD of 3587 and 1819. The order is going to be immaterial, but for the algorithm to get executed, you will have to first initialize to this stage. Now what I am going to do is I am going to form 4 columns over here, which will give me A when divided by B leaves me a quotient Q and a remainder R. So I am having 4 columns, a Q, a B and R. What do you do over here is first enter the biggest element under A, 3, 5, 8, 7, and the smallest element under B, 1, 8, 1, 9. So this is my A, GCD of A comma B. Now A becomes 3587 and B becomes 1889. Okay, so keep in mind first A has to be big and B has to be small. Okay, not B is for big, B is for small. Okay, now you divide 3, 5, 8, 7 by your 1819. How many times it goes? It goes 1 time, and now 1819 on subtraction leaves us a remainder of 1768. This is my quotient. This is my remainder. Mark the entries over here. 1 time and the remainder is 1768. Is my remainder 0? No, the remainder is not 0. So I will have to repeat the algorithm. How do I repeat? Replace A by B. A is now replaced with B. So this 1819 enters the position of A and replace B with R. B now is replaced with R. 1768. So in the next stage what we do? This 1819 is being divided by your B, which is 1768. How many times it goes? Again it goes 1 times, and 1768 on subtraction leaves us a remainder of 51. Now again enter the quotient over here with 1 and the remainder as 51. Is the remainder 0? No. So we again execute the algorithm one more time, replacing my A as 1768 and my B with the remainder 51. Divide this biggest number 1768 by the smallest number 51, which is B. How many times this goes? It goes 34 times. Now leaving us 34 times of 51 is going to be 1, 7, 3, 4, and now it again leaves us a remainder of 34. So enter the quotient as 34 times of this quantity, leaving a remainder of 34. Is 34 0? No. So repeat the process. So take in your 51, take in your 34, divide your 51 by 34. How many times it goes? It goes one time with 34, leaving a remainder of 17. So I enter the remainder 17 and quotient over here. Is the remainder 0? No, remainder is not 0. So again execute the algorithm. So 34 comes here and the remainder 17 comes to the position of B. Now 34 is going to be divided by the smallest number 17. Does 34 go in 17? Yes, it goes 2 times 34 and leaves us with a remainder 0, which is exactly divisible. So the remainder now becomes equal to 0. And how many times it has moved? It has gone 2 times. Therefore, we stop the process of algorithm as we have got the remainder as 0. Now, what is going to be the GCD? The value in my position B is my GCD. What is going to be the value in my position B? This is my position B, and hence 17 becomes the GCD of the number 3587 and 1819. So, we conclude that the GCD of 1819 and 3587 is going to be equal to 17. We can also say by one more way that the last non-zero remainder is going to be the GCD. So what was the last non-zero remainder? The last non-zero remainder was 17. So this 17 only is entering here. Okay. So the last non-zero remainder can also be taken as the GCD. We'll quickly try it for one more problem. Find the second problem. GCD of the numbers 512 and 320 using the Euclid's algorithm. Okay. So form your columns Q, A, B and R. Okay. So now make your entries. Which is the biggest number? We are allowed to check. This is A, B. Is A big and B small? Yes, it's correct. So we will keep it as the same way. 512, 320. When 512 is divided by 320, now how many times it goes? It goes one time, and when I have 320, it leaves a remainder of 192. 192 is entering here, and the quotient is going to be equal to 1. Remainder non-zero, so swap the numbers. 320 and 192 enter here. Repeat the process. 320 is divided by 192. How many times it goes? 1 times, leaves a remainder of 128. So this remainder is now entering the position 128 and quotient gets value 1. Non-zero remainder. So repeat the process. 192, 128, and now the process is divide 192 by 128. It goes one time and it leaves a remainder of 64. So enter the 64 over here and the quotient over here. Again non-zero remainder. So repeat the algorithm. 128, 64. So 128 is divided by 64. So does 128 goes in 64? Yes, it goes 2 times. 2 times of 64 makes it as 128, leaving you a remainder of 0. So the remainder has become 0 for me. So the algorithm stops. So now what is going to be the GCD for me? The GCD is going to be the one in the position B. So what is there in the position B? 64, which is the same as the last non-zero remainder, which is over here. Hence, what do we conclude is the GCD of the given quantity 512 and 320 is going to be 64. Hope the process of Euclidean algorithm is going to be a easy one to catch up after this viewing of video. If there is going to be further more doubts, please do ping me in the comment box. We will see how we can help you to learn things in a better way. Happy learning, keep learning.